discuss about the functions of the liver. Although the liver is a discrete organ, it performs many different functions that interrelate with one another. This becomes especially evident in abnormalities of the liver because many of its functions are disturbed simultaneously. This chapter summarizes the liver's different functions, including 1. Filtration and storage of blood, 2. Metabolism of carbohydrates, proteins, fats, hormones, and foreign chemicals, 3. Formation of bile, 4. Storage of vitamins and iron, 5. Formation of the coagulation factors. Now let's discuss about the physiological anatomy of the liver. The liver is the largest organ in the body, contributing about 2% of the total body weight, or about 1.5 kilograms, that is 3.3 pounds, in the average adult human. The basic functional unit of the liver is the liver lobule, which is a cylindrical structure several millimeters in length and 0.8 to 2 millimeters in diameter. The human liver contains 50,000 to 100,000 individual lobules. The liver lobule, shown in cutaway format in figure 69.1, this is constructed around a central vein that empties into the hepatic veins and then into the vena cava. The lobule itself is composed principally of many liver cellular plates, two of which are shown in the figure 69.1, that radiate from the central vein like spokes in a chain, like spokes in a wheel. Each hepatic plate is usually 2 cell thick, right, and between the adjacent cells lie small bile canaliculi that empty into the bile ducts in the fibrous septa, separating the adjacent liver lobules. In the septa are small portal venules that receive their blood mainly from the venous outflow of the gastrointestinal tract by the way of the portal vein, which is present. Portal venules are present in the fibrous septa. From these venules, blood flows into the flat. From these venules, blood flows into flat. From these venules, blood flows into the flat branching hepatic sinusoids that lie between hepatic plates, and then into the central vein. You notice one thing: the liver lobule has cell plates, which is 2 cell thickness. The adjacent hepatic cells are divided by or separated by the uh, bile canaliculi, right? Likewise, the adjacent liver lobules are separated by the fibrous septa, right? Likewise, the in between the hepatic plates, there is hepatic sinusoids, right? In between the cell plates, there is hepatic sinusoids the, that lie between the hepatic plates, and these hepatic sinusoids opens into the central vein, right? Thus, hepatic cells are exposed continuously to the venous blood. Thus, the hepatic cells are exposed continuously to the portal venous blood. Hepatic arterioles are also present in the interlobular septa. Not only hepatic venules, hepatic sinusoids. The hepatic arterioles are also present in the interlobular septa. These arterioles supply arterial blood to the septal tissues between the adjacent lobules. Right? These arterioles supply arterial blood to the septal tissues between the adjacent lobules, and many of the arterioles also empty directly into the hepatic sinusoids, which lie in between the lobules, right, liver lobules, most frequently emptying into those located about one third the distance from the interlobular septa, as shown in the figure 69.1. This is the figure 69.1 showing the basic structure of a liver lobule, showing the liver cellular plates, the blood vessels, the bile collecting system, and the lymph flow system, composed of the spaces of the disc and the interlobular lymphatics. Interlobular lymphatics, right? In addition to hepatic cells, the venous sinusoids are lined by two other cell types, namely 1. Typical endothelial cells, and 2. The large Kupffer cells. And the large Kupffer cells, also called reticuloendothelial cells of the liver, which are resident macrophages that line the sinusoids and are capable of phagocytizing bacteria and other foreign material in the hepatic sinus blood. The Kupffer cells phagocytize bacteria and other foreign matter in the hepatic sinus blood. The endothelial lining of the sinusoids has extremely large pores, right? Some of which are almost 1 micrometer in diameter. Beneath this lining, lying between the endothelial cells and hepatic cells, are narrow tissue spaces called the spaces of Disci, also known as perisinusoidal spaces. Perisinusoidal spaces, right? The millions of spaces of Disci connect with lymphatic vessels in the interlobular septa. Therefore, excess fluid in these spaces is removed through the lymphatics. Because of the large pores in the endothelium, substances in the plasma move freely into the space of Disci. Even large portions of plasma proteins diffuse freely into these spaces. Now let's have a discussion of this hepatic, vascular, and lymph systems. The function of the hepatic vascular system is discussed in chapter 41 in connection with the portal veins and can be summarized as follows, right? The liver functions as a blood reservoir because the liver is an expandable organ. Large quantities of blood can be stored in its blood vessels. Its normal blood volume, including both that in the hepatic veins and that in the hepatic sinuses, is about 450 ml, or almost 10% of the right body's total blood volume. When high pressure in the right atrium causes back pressure in the liver expands, and 0.5 to 1 liter of extra blood is occasionally stored in the hepatic veins and sinuses. This occurs especially in cardiac failure with peripheral congestion, which is discussed in chapter 51. Now, second function, the liver's macrophage system serves as blood cleansing function. Macrophage system is mainly the Kupffer cells, which will remove the bacteria and other foreign matter. Blood flowing through the intestinal capillaries picks up many bacteria from the intestines. Indeed, a sample of blood taken from the portal veins before it enters the liver almost always colon bacilli colon bacilli when cultured, whereas the growth of the colon bacilli from blood in the systemic circulation is extremely rare. The Kupffer cells, that is, reticuloendothelial cells of the liver, which are large phagocytic macrophages that line the hepatic venous sinuses, probably less than which line the hepatic venous sinuses efficiently cleanse blood as it passes through the sinuses. Probably less than 1% of the bacteria entering the portal blood from the intestines succeeds in passing through the liver into the systemic circulation.